So I hope you enjoyed the video that was prior to it. Just a little bit of me running someplace this weekend. Kind of had fun. Was out on the trails. Would have been a couple weekends ago now. Ran through some water, as you've seen in the slow motion, kind of that slow motion thing. So hope you enjoyed the video. Just, I don't know, change it up a little bit from just the same old, same old. So anyway, in this video, we are going to cover section 2-2, which is standard form of quadratic functions. Yesterday, we took care of, or the last video, we took care of, sorry, that's really loud. I noticed when I was making the videos when I do that with my hands. It's just fidgety. Last video, we talked about vertex form of a quadratic function. Now today, we're going to talk about standard form of a quadratic function. So how do you find the vertex of a quadratic function written in standard form? So first and foremost, what's standard form? Standard form for a function, for a quadratic function, is f of x is equal to a of x squared plus b of x plus c. So that's the standard form of a quadratic function. Now understand that a, b, and c are just real numbers. And a can't be 0, because if a is 0, then you've got linear. You've got kind of a linear piece of it. So if you read kind of what they're doing now, it's the division, it's the proof. You like geometry so much, honors geometry so much, or advanced geometry here at the high school. You love doing proofs so much. Here's the proof of kind of everything that talks about how really this can happen. So again, it's just the proof, the equation, a of x, blah, blah, quadratic function, standard, blah, 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 blah. So the keys starts to come down here. Okay, so we still want to be able to find kind of those key functions that we were able to do before. The domain, the range, the axis of symmetry, the vertex, and probably a couple other things when we're talking about quadratics in standard form. We still want to be able to, in a sense, graph it. So we have to have kind of those key features. So the key features are always going to be kind of your vertex. And how do we go about finding that vertex? If we know the vertex, then we know the axis of symmetry. Well, if we know the axis of symmetry, we know the vertex, because we can just do some kind of plugging in there. If we can find that vertex and that axis of symmetry, if we can find another point on one side, the corresponding part's going to be on the other side. So we want to be able to find that vertex. And the way we're going to find that vertex is we're going to start by finding the axis of symmetry. So to find the axis of symmetry, what we are going to do essentially is we are going to use this equation that's sitting right here. Now remember, our h value is our x value in our quadratic. So it says the vertex of the quadratic function h of k. You can do that to determine the vertex by solving that for h. Well, when we do that, you get h is equal to negative b over 2a. Now remember that h is just the x-coordinate of the vertex. So if we want to find the x-coordinate of the vertex, we can set x equal to negative b over 2a. That's going to give us the x-coordinate at the vertex. And if we can find that x value at the vertex, we can use that value to find the y value by plugging that x value in. And then that's going to give us the y value at that vertex. So then we've got that y value. Now remember also, now that we've got that x value, that's the axis of symmetry. So that's telling us kind of that vertical line that we're going to have as well. So it's really doing two things. It's giving us that axis of symmetry, the x value, but it's also then allowing us to find the vertex by plugging that x value in and finding your h value kind of in there. So that's the standard form of an equation of a quadratic function. Big key out of this, the other thing you need to know is the axis of symmetry is x is equal to negative b over 2a. And we're going to use that quite a bit here during this section. So what is the vertex of that function? So let's do an example. So we've got f of x is equal to x squared minus 6x plus 10. So the first step that you're going to want to do with this is you're going to want to identify your a, b, and c value. Now remember, standard form is ax squared plus bx plus c. So your a value, your b value, and your c value are really always given to you. So our a value is the value out in front of the x squared. So in this case, there's nothing there, so it's 1. And notice it's plus, so our b value is -6, and our c value is 10. We're going to use those things then to find the axis of symmetry. So in order to find the axis of symmetry, after we've found that, we're going to use x is equal to or h is equal to, it's the same thing. X is equal to negative b over 2a. Well, we know our b value is -6, so we've got the negative of -6 over 2 times 1. And when you get that, it's like they have 3 in there. Now that we've got that 3, that's our axis of symmetry line. We're going to use that 3, so in our vertex, we know the x value of our vertex is going to be 3 right now. We have to find that y value. So what we're going to do to find that y value then is we're going to go ahead and substitute that value that we know x is, and we're going to substitute it into each of our spots in our original quadratic function. So we substitute that in there, 3 squared minus 6 times 3 plus 10, and you get 1. That gives us the vertex of that function of 3, 1. So you find the axis of symmetry first by using x is equal to negative b over 2a. Once you've found that axis of symmetry line, you use that x value, substitute it back into your y value to find the x value, then you've got your coordinates. So let's look at an example. What is the vertex of the graph? F of x is equal to x squared minus 8x plus 5. So I like to do the a, b, and c first. So I'm going to list my a values. My a value, there's nothing there, so it's 1. My b value is -8. My c value is 5. Well, I know kind of probably what's going through your head right now. Why do we have to list the c value? It's not going to help us. It's going to in a minute. Not to necessarily find that, but it's going to help us graph it and define the key features. So we're always going to list the a, b, and c. So now the axis of symmetry. So the axis of symmetry is x is equal to negative b over 2a. So if we plug that in there, that's the negative of -8 over 2 times 1. So that's 8 over 2 or 4. So my x value at the axis of symmetry is 4. The axis of symmetry itself is a line. So that's the axis of symmetry. 4 helps us find our y value. So now we can go ahead and find our y value. And we're going to do that by substituting 4 into our x values. So we'll change to blue. So we've got 4 squared minus 8 times 4 plus 5. So 16 minus 32 plus 5. I believe that's -11. So -11 goes in there. So our vertex for this is for -11. And you're done. That's finding the vertex of a quadratic function. A, B, and C, find your axis of symmetry, negative b over 2a, plug that back in to get your other piece then. So when we were doing the quadratic, the vertex form, we then talked about the key features. So we want to be able to find the key features in here as well. So when we're talking about those key features, kind of what we're looking for is we're looking for that axis of symmetry. We're looking for the vertex. We're looking for probably another point on the graph, maybe a Y-intercept, and another point maybe that's going to be symmetrical to kind of help us graph this piece, because and ultimately that's what we want to do. So there are really 4 steps in doing this. The first step is going to be to find the vertex. Okay, so that's kind of the first step here, is to go ahead and find the vertex of this and the axis of symmetry. So we're going to find that axis of symmetry. My A value is 1. My B value is -4. My C value is 8. So x is equal to negative of -4, so 4 over 2. Just kind of skipped a step in there. You should be able to do that. Negative of -4 is 4. 2 times 1 is 2. So there's my axis of symmetry. So if they're just asking you for the axis of symmetry, the axis of symmetry is x is equal to 2. If you're asked to find the vertex, we know the x value at the vertex now is 2. We have to find the y value at the vertex. So we're going to substitute it in there. So that's 2 squared minus 4 times 2 plus 8. That's 4 minus 8 plus 8. 4 minus 8 is -4 plus 8, so 4. So here is my vertex. So I've got this vertex and I've got this axis of symmetry. So that's step 1. Step 2, find the y-intercept. Okay, the y-intercept. What's my x value at the y-intercept? Well, my x value at the y-intercept is 0. So to find the x-intercept, I'm going to set my x value equal to 0. So f of x, which is a fancy way of saying y, is equal to 0 squared minus 4 times 0 plus 8. So that's y is equal to 8. So my y-intercept is the point 0.8. Well, what do you notice? This is 8, and so is my c value. It's not coincidence, okay? That y-intercept is always going to be the point 0c. It's kind of the fast way to do it. You don't need to do it that way all the time. It's just 0c. So that's going to be your y-intercept. Now, step 3 is to find a point symmetric to the y-intercept across the axis of symmetry. I'm going to go right into step 4 and we'll come back to that. So if we're going to graph this, always start by graphing its vertex. Its vertex is 2, 4. Over 2, up 4, it's in that area right there. Done, we've got that graphed. I'm going to move it down just a little bit to kind of help me out a little bit, because where I have to go next. The next thing you got to kind of think about is, does this go up or down? Well, what's the a value? If the a value is positive, it goes up. If it's negative, it goes down. So I know this graph is going to go up. Okay, so we can kind of envision it going like this. We know the y-intercept. We know the y-intercept is 0.8, which is right there. So we can kind of sketch this part of the parabola. This part of the parabola is going to kind of go like this. Now, we also know our axis of symmetry line. Our axis of symmetry line is the line that goes through the vertex, or x is equal to 4. So we know that that's the line x is equal to 4. So we have this vertex point, and I'm just going to write this vertex point. This is the point 2, 4, and we know that this is the point 0.8. Well, here's what has to happen. Since that's an axis of symmetry, this distance right here and this distance right here have to be the same. So if we need to find a third point to help us kind of graph this, if I can name this point, I've kind of got that third point. And that's what step 3 is. It's finding that point symmetric to the y-intercept. Well, this distance right here is 2, so this distance is 2. So that means that distance has to be 2. So 2 plus 2 is 4. So this is the point 4.8. So my point that's symmetric to it is the point 4.8. And my graph is going to go something like that. So it's a 4-step process. Find the axis of symmetry, that's going to help you find the vertex. Find the y-intercept. Find a third point. You might do that after you start sketching the graph, so that you can find a point that's symmetric to the y-intercept across the axis of symmetry. And then you're going to graph it. Okay. One thing, caveat that's not really in here, is you got to make sure if it goes up or down. Remember, if A is positive, it goes up. If A is negative, it goes down. We talked about that in the first section. And that's no matter if it's in this form or if it's in vertex form for this. Okay, so let's look at another example. So we're going to list the key features for x squared minus 6x minus 1. So a is equal to 1. A is not always 1, just what it seems to be today. B is negative 6. C equals negative 1. So my axis of symmetry, AOS, x is equal to negative b over 2a. So negative of negative 6 over 2 times 1. So that's 3. So then I can find the vertex. My vertex is 3 something. We got to find that something. We find that something by substituting it in. 3 squared minus 6 times 3 minus 1. So 9 minus 18 minus 1, which is negative 10. So we get a vertex of negative 3, negative 10. I think that looks right. The Y-intercept is the point 0C, so 0, negative 1. Now, as I'm going to go ahead and graph this. So let's go ahead and graph this. So we're always going to start out by graphing the vertex. 3, negative 10, and it's down there somewhere. If you want to draw the axis of symmetry line in there, it doesn't hurt. There's our axis of symmetry line. If you need to put what point that is to kind of help you out for later on, you can do that. Your y-intercept is 0, negative 1, which is right there. So that means our graph goes something like this. We have to find the other side of this. So if we know this distance right here, come on. I'm going to put this point at 0, negative 1. So we want to find this distance here. We look at our x value is 3, so that's going 3, so that's 3. So that right there is going to be the point 6, negative 1. So there's our other one. The y values is going to be the same as that one. That x value is 6. And there are the key features of that one. All right, so kind of just like yesterday, here's a good place to put pause. The only difference is this time I'm going to kind of keep the video going. It's a good place for you to hit pause and then do really the first part of the assignment. If you see me looking up and to the left, it's because I'm just double checking what your assignment looks like for the day. It's this one. Sorry. So you're looking at the first really 5 or 6 of these to do. And then we're going to move on to the second part. So I put pause right now because what we're doing next is going to take just a little bit of time. All right, so welcome back if you took the pause. If you didn't, we're going back at it. And now we're going to do the fun stuff. This is why we did the systems of equations right before break. And right before this distance learning thing is so we could do problems like this. So the question for these is going to be, what is the equation of a parabola that passes through 3 points? So now we've got this parabola that's going to pass through these 3 points. And we don't know kind of maybe what points these are. We've got negative 3, negative 2, 32, which is way up there. We've got 1, 5, which is right there, and 3, 17 is right there. So it looks like it's going to be kind of like this, but we don't know. I mean, we don't know where this vertex is. We know this is going to be going up probably at this point. It's going to be coming down, but we don't know if that's the vertex or not. They don't tell us it's the vertex, so we can't assume that it's the vertex. It very well may come through there, but it may go down like this. We don't know what this is going to do. So we want to be able to write the equation of this. The way we do this is we're going to create 3 equations with 3 variables using our 3 points. So we're going to write each of these using the x values and y values that we know. We're going to write 3 systems of equations with 3 variables, replacing our x's and our y's with each of them. So the first thing that we're going to do is we're going to take the first point that they give us, negative 2, 32, and we're going to write that out. So anywhere we see a y value in our thing, we're going to replace it with 32, and anywhere we see an x value, we're going to replace it with negative 2. So we would get 32 is equal to negative 2 squared plus b times negative 2 plus c, and we'll simplify that in just a little bit. Then we're going to go to the second point, 1, 5. Anywhere we see a y value, let's go back up to this one and let's just rewrite it. So that's 32 is equal to 4a minus 2b plus c. And they wrote it down there, but whatever. So the second one, anywhere we see a y, we're going to replace with a 5, and an x we're going to replace with a 1. So that gives us 5 equals 1a plus 1b plus c. There's our second one. And then we're going to use the third point, 317. Anywhere we see a y value, we're going to replace with a y. Anywhere we see an x, or with a 17, anywhere we see an x, we're going to replace with a 3. So 3 squared is 9 plus 3b plus c. So now we have this lovely, lovely, lovely systems of equations. Ooh, and this is a good one too. No, it's not too bad. Now we're going to solve that. So we're going to go back to a little bit of review. And all this is allowing us to do is it's allowing us to find the equation of this. So then if we wanted to find the vertex, if we wanted to find the axis of symmetry, we can find all of those different things. Right? So here is our 3 equations. Let's get this away from green. Let's go ahead and solve this system of 3 equations with 3 variables. So the first thing I'm going to do, just like the other day, I'm going to label them 1, 2, and 3. And I think I'm just going to go 1 minus 2. So it's backwards. I don't work backwards well in my head, so I'm just going to rewrite it as 4a minus 2b plus c minus 5, and oops, of course I put minus 5, minus a, I'm going to put the minus in there, minus, so it says plus b minus plus c, and both that top one equaled 32 and this bottom equaled 5. So we're going to subtract. So 4 minus 1 is 3, so that's 3a. 2a minus b is minus 3b equals, c's go away, 27. So there's the first one. Now I'm just going to do 2 minus 3. It's because that's easiest for me to do. So I'm going to go 2 minus 3. So that's a plus b plus c equals 5 minus 9a plus 3b plus c equals 17. And so I'm going to make sure that I remember I'm subtracting. So a minus 8a is negative 8a. b minus 3b is minus 2b. C's go away. 5 minus 17 is negative 12. Yuck. So now I've got my equations. My 2 equations with 2 variables. So I've got 3a minus 3b equals 27, and negative 8a minus 2b equals negative 12. Yuck. Is what it is. So I'm going to multiply this top one by, I don't know, 8, and the bottom one by 3. So that's 24a minus 24b equals 8 times 27. 216. And then negative 24a minus 6b equals negative 36. So those go away, so negative 30b equals 216 minus 36, 180. So b equals negative 5. It's a whole number. Works for me. So b is negative 5. So we're going to take and substitute it back into one of them. It doesn't matter. I'm going to go ahead and go with 3a minus 3 times negative 5 equals 27. So 3a plus 15 equals 27. 3a equals 12. A equals 4. So there's my a value. Sorry, I'm running out of room. Now we got to find the last one. So just for space, I'm going to go ahead and plug it in up here. Now, I can make it work. So we've got 32 is equal to 4 times a, so 4 times 4 minus 2. We're going to get rid of this. Let's see if we can add a page in here. Yeah. The one bad thing about this is I can't really put it in there. So I'm just going to erase this over here since we've already used it a little bit. Okay. So we've got 4 times a, so 4 times 4 minus 2 times b, which is negative 5, plus c equals 32. So 16 plus 10 plus c equals 32, so that's 26. So c is equal to 6. So there's my c value. So then my final is f of x is equal to a times x squared, so 4x squared, plus b, so well b is negative 5. So we've got 4x squared minus 5x plus 6. There's the equation of a line, of a parabola, with those 3 points. Oy caramba. Another long problem. Should we look at another one? Probably. All right, so let's look at the next one. So what is the equation of a parabola that passes through the points? Hey, press pause. I mean, if you want to try it yourself, you can always just press pause and then come back and we'll lead you through it. So step 1, we're going to rewrite our equations. Okay, we're going to write them as equations, replacing our x's with our x's and our y's with our y's. I'm writing 3 of them. So my y is negative 12, so I'm going to have negative 12 is equal to a times x squared. So a times 2 squared plus b times x, so b times 2 plus c. So negative 12 is equal to 4a plus 2b plus c. So there's my first one. Second one. We're going to go negative 15 is equal to a times negative 1 squared plus b times negative 1 plus c. So negative 15 is equal to 1 squared is 1, so that's a minus b plus c. There's my second one. Third one. C value or y value is negative 90 is equal to a times negative 4 squared plus b times negative 4 plus c. So negative 90 is equal to 16a minus 4b plus c. So there's my third one. Yay! We've got that part. All right, so now we need to solve the system. So we've got, we're just going to rewrite them. So we've got 4a plus 2b plus c is equal to negative 12. We've got a minus b plus c. A minus b plus c is equal to negative 15. And 16a minus 4b plus c is equal to negative 90. So there are our three. Now we're going to solve them. 1, 2, 3, and do the same thing we did last time. 1 minus 2. And I'm just going to do it up there now. Try to keep it straight in my head. So 4a minus a is 3a. 2b minus negative b, so 2b plus b is 3b. C minus c goes away. Negative 12 plus 15 is 3. So we've got 3a plus 3b equals 3. And then I'm going to do 2 minus 3. Again, I'm just going to do it up there. A minus 16 is negative 15a. Negative b minus negative 4, so negative b plus 4, oh yay, plus 3b equals negative 15 plus 90. Just making sure we get it right, so 75. Now it looks like I can just subtract these. So if I subtract these, so I'm just going to put a little minus in between all of them. So you get 18a, those go away, equals 3 minus 75 is negative 72. 72 divided by 18, please work, please work, please work. So you get a is equal to negative 4. There's my a value. I'm going to plug it into here, so 3 times negative 4 plus 3b equals 3. So negative 12 plus 3b equals 3. 3b equals 15. b equals 5. C, I've got this one, so I'm going to use this one. So we've got a, negative 4, minus b, which is 5, plus c equals negative 15. So that's negative 9 plus c equals negative 15. c equals negative 6. So now I can write my function. F of x is equal to a times x squared, so negative 4x squared, plus bx, so plus 5x minus 6. There's the equation. Ta-da! So these do take some time. Okay, now if we were asked to find the vertex, we were asked to find the axis of symmetry and graph and see kind of what this thing looked like, we could. But that's taking it and going through 3 different points for this. So that really finishes up lesson of section 2. Identifying things that are written in standard form, being able to identify the vertex, the axis of symmetry, the Y-intercept, finding another point, and then being able to graph them when they pass through 3 points. So you've got the PDF. On the PDF, you do need to do questions 1 through 6. And then on the bottom part, the 7, 8, and 9, there are 3 of them that pass through 3 points. Pick 2 of them. I don't care which ones you do. Just pick 2 of them. 7 and 9, 8 and 9, 8 and 7, whatever. Just pick 2 of the 3. You don't have to do all 3. So that takes care of section 2. Yeah. Hope you did well on the test. Next lesson that we will cover is section 2-3. 2.3, we did the standard form. Section 2.3 is the factored form. So we did vertex form, standard form, and then we're going to talk about factored form. So factored form means we probably have to talk a little bit of factoring. Yay, everybody loves to factor and find those other points. That's all this is really doing. So see you next time.